So today we're going to be looking at the properties of logarithms. Tomorrow, or sorry, not tomorrow, but the next lesson, maybe tomorrow for you, maybe another day. Anyway, the next lesson is going to cover solving exponential equations, and we're going to be using logarithms to do that. Okay, so it's super important we understand these logarithm things. Again, these are a little bit funky for students to understand, so we'll go through these properties here a little bit step by step, and then we'll do a couple problems too. Okay, again, you'll see these more in pre-calculus if you plan on going on in pre-calculus, and also in calculus too. You definitely want to have it down, I would say, by the end of pre-calculus though, for sure. Okay, anyway, so properties. All right, so again, you know, this is something people sometimes gloss over, but it is important to recognize here that whenever we talk about A or M or N or B and C, we're all assuming that these are positive. Okay, and additionally, we are assuming that B is not 1 and C is not 1 either. Okay, so let's highlight some basic properties first. Okay, number 1, log base B of B to the M is M. Okay, this should make sense, okay, because if you have log base B of B to the M, and you want to know what that equals, right? Remember, this is like saying, if we rewrite an exponential form, b to the what equals b to the m. Well, if they have the same base and they're equal, then what must be true about their exponents? These two also must be equal as well. Okay, so that's why we just get the m there at the end. Okay, because that's got to be the power there by the, rewriting exponential functions and rewriting logarithms to exponential form. Okay, likewise, same kind of situation here. Okay, again, if you just take log base b of 1 and you set it equal to, well, who knows, right? Rewrite an exponential form, b to what power is going to give us 1? Well, the only way you can raise something to a power and get 1, right, if your b is not 1, right? Remember, b is not 1. So anyway, you can take a non-zero number, raise it to an exponent, and get 1 is if the exponent is 0, right? So that's why this has to equal 0 here. Right? Okay, so pretty straightforward there. And then the last one too, log base b of b is 1. Now this one follows from number 1, really, okay? Just, again, b by itself there is the same thing as b to the 1. So log base b of b to the 1 should be just 1, just like log base b of b to the m is just m, okay? So keep that in mind there for those properties. Now, those are the basic properties. Then we have some additional properties that show up too. We have a product inside a logarithm, we have a quotient property inside a logarithm, and we also have power property when we have power inside the logarithms too. So notice here, we have log base b of m times n. So we have a product inside of our logarithm. How can we, what's that equivalent to? It's equivalent to breaking up this product into two logarithms that we add together. Okay, so it was m times n, it becomes log base b of m plus log base b of n. Okay, note, log base b of m plus n does not equal, in general, log base b of m times log base b of n. So we can't break up addition inside of a logarithm like we do the multiplication. It doesn't kind of work backwards, okay? So this works, right? If you have multiplication inside, it becomes addition outside. So you can go this direction, right? Also, if you're adding two logarithms together with the same base, okay, then you can, if you're adding two logarithms together like we are here, two separate logarithms together, then you can combine those together to a single logarithm with a product on the inside. But if you have an addition on the inside, that does not break up into two logarithms. Okay, so just be careful with that. Sometimes students generalize this too much, and that's, no, we can't do that, okay? All right, then for the quotient property, similar kind of idea, right? If we had multiplication and that resulted in addition, then it would make sense that if you have division inside a logarithm, it results in subtraction, right? And again, in general though, if you have subtraction inside, it does not equal division on the outside between these two things. Okay, so again, do not do this. Okay, you cannot really simplify subtraction inside a logarithm or addition inside a logarithm unless those numbers are already like terms in the first place. And then finally, we have log base b of m to the n power here. Okay, so what that allows us to do is to bring this n exponent out front of the log base b to the log base b of m. Okay, this is really just an extension of our product property. Okay, when you think about it, right? Log base b of m to the n is like saying log base b of m times m times m times m times m times m, and there's n number of those m's, right? And so that would convert to log base b using our first property, right? That converts to log base b of m plus another log base b of m plus another log base b of m, because again, this is all one product in here, right? And so that would convert to all addition between separate logarithms. I'm not going to write all those out. Again, there would be n of these. When you add up a bunch of things n times, right? That's the same thing as n times log base b of m. Again, remember that the word times is just how many times you're adding the thing up to itself, kind of thing. Okay? So anyway, that exponent on the inside can go out front like this and multiply with the logarithm on the outside. Okay? So let's use these properties then to rewrite each expression as a single logarithm and then simplify further if possible. So let's look at this right here. All right, right away I see two logarithms and there's subtraction between them. So looking up here, there's two logarithms with subtraction between them. That can convert to a single logarithm with division on the inside. So the log base 3 stays, right? The base does not change, but we'll rewrite this as 27 over 81, which if we simplify that, we can divide and we get 1/3, and then 1/3 further simplifies because 3 is our base, right? 1/3, remember, is the same as, is the same as saying log base 3 of 3 to the negative 1, and then using our property right here where our base is 3 and the base here is 3 as well. Okay, that means we're just going to get our exponent there of negative 1. Now, another way you could have done this, and maybe you guys saw this from before, you guys could have done this before we did our properties today. We already know what log base 3 of 27 is. Log base 3 of 27 is 3 because, 3 to the third equals 27, so that's why this is 3. Okay. Likewise, log base 3 of 81 is 4. What's 3 minus 4? Negative 1, which is what we got. Okay, let's take a look at number 2. Log base 5 of 1/25 plus log base 5 of 625. Again, we could do this a short, easy way of just saying, okay, well, this simplifies to negative 2, and this simplifies to, let's see, your 5 times 5 is 25, times another 5 is 125, so times 4, so plus 4 gives us 2. But let's go ahead and use our properties too. Again, we have now addition between these two logarithms. Addition between two logarithms becomes multiplication inside. So it's going to be 1/25 times 625 inside, which would just simplify to be, excuse me, 125. No. It will simplify to be 25. Okay? And then so now we just take the log base 5 of 25, which is 2. So you see you get the same answer. All right, let's try another one. All right, here we've got log base 4 of 64 to the third. So here we have an exponent inside our logarithm, which if we scroll back up here is this property right here, right? We have an exponent inside our logarithm. So that 3 can go out front. Okay, 64 is the same thing as 4 to the third, and so 3 times log base 4 of 4 to the third, which means this is just equal to 3 as well. So we get 9 as our final answer. Alternatively, right, I could have rewritten the 64 as 4 to the third, and then since it was 64 to the third, it becomes 4 to the third to the third. Power to a power, we multiply the exponents. like so. And we can just use our first property that we talked about at the top there, and this will again just be 9. So again, you can see two different ways to do the same thing there. All right. Let's see, I got 2 more here for you. All right. So again, this one, I see subtraction. What does subtraction become? Division. So it's log base 3 of 18 over 2, which simplifies to 9. And 9 is 3 squared, so this becomes 2. Okay. Again, I can rewrite that as a little more explicitly if you need to. There you go, like that. And so 2, by using that first property. This is nice here, okay, right? We don't have the second option like we did in some of these other ones, like we did here and all the previous ones. Because what's log base 3 of 18, right? 3 to what power gives you 18, right? I don't know, right? It's going to be some number between 2 and 3, right? So not very helpful. Right, likewise here, 3 to what power gives you 2, right? If I rewrite this logarithm as exponential form, okay, 3 to what power gives you 2? Again, not really sure, but it's some number between 0 and 1, right? So again, not super helpful. But when you simplify this using your properties, we suddenly are able to simplify this logarithm very nicely to just 2. So in other words, this whole thing is just equal to 2. Nice number 2, okay? And then finally here I threw in some variable stuff too. Now notice these logarithms don't have any bases. What is the base of a logarithm? What number is the base of the logarithm if there's no number written? Remember, these are all 10. Whoops. Okay, so let's combine this together. Now we're going to follow order of operations here, so I have parentheses first, and that addition inside the parentheses. So that means the addition, whoops, becomes multiplication. So I'll have log of y times z on the inside like that. Okay, now I can kind of drop these parentheses here. I'm going to subtract 2 logarithms. Subtraction becomes division. Ooh, but first I need to take care of this 2. So let's bring that 2 up as an exponent, right? It's kind of like the reverse of this property right here, right? Where I have a number in front, so I can bring that up to be the exponent of the m, like you see right here. Okay, so this will become log of x squared minus log of y times z. And now we have subtraction, so I can change that to division. Okay, since y times z was the entire, was all that was in the logarithm there, that whole quantity goes in the denominator. And there's our final answer. If you want to put a 10 there, you can. You don't have to write a 10 though. If you don't write a 10, it's understood that a 10's there. Okay, let me know if you guys have any questions. Thanks, and good luck on the homework. Have a good day, guys.